So here, this part, I'm going to introduce you. I'm going to change into laser pointer first. I'm going to introduce you about the marine sources. So basically, different marine sources have different energy level and frequency characteristics. Besides, the fundamental application is totally different from the previous environment, which is land. Move on. So technically, there are two common type of marine sources known as air guns and sparkers. So both create a shock where surrounding an air bubble in the water, and concept is quite similar to the dynamite in sense of blasting. However, it can be controlled and less hazardous. If you look at these slides, the vessel is towing the receivers here, as well as the energy sources, a type of energy source. So basically, this is the schematic how we conduct a seismic survey in marine. So after marine source is blasting here, a shock wave will be produced by rapidly compressing the water molecules in the vicinity of the source, and then it spread out and travel downward through sediments or rock underneath, and will be reflected when it finds the contrast in acoustic impedance. So we move first to the first type of marine source, which is air guns. So in wetly areas such as swamp or marsh, sometimes dynamite is not going to work very well and hard to control in terms of positioning and blastings, and thus the air gun is introduced to replace dynamites. So here is a video showing the how the air guns is working. I need to change it into cursor first. Okay, now we can play the video. So air guns are pneumatic sources in which chamber is charged with compressed air, like here, and fed with a hose from a shipboard compressor as the air is released by electrical triggering through the side vents into the water in the form of high pressure, with an operating range of pressure around 10 to 15 megapascals, and with frequency of 10 to 100 hertz, and it has the best signal strength compared to the other source such as a boomer or sparker. So I'm going to explain more on detail in the next slides on how it is operated. So now here is the figure for the basic schematic cross section of the air gun. So on the left is in arm position, in which the air gun is in standby mode, while on the right side here where when it is fired. So basically we have two chamber over here, on the top and the bottom. So on the top one is known as upper control chamber, and the bottom one known as discharge chamber. So before I go in detail, I have a video that explaining the operation undergone of the air gun. So let's listen and watch the video, and I will elaborate it afterwards. I need to change it into again to the cursor so that we can play the video. Okay, listen.
A modern air gun seismic source element comprises of two high-pressure air chambers, an upper control chamber and a discharge chamber. High-pressure air, typically at 2,000 to 2,500 pounds per square inch, or PSI, is supplied to the upper control chamber from the compressor on board the seismic vessel via an air hose, and slowly moves into the lower discharge chamber through an opening in the shuttle assembly. The source is activated by sending an electrical pulse to the solenoid valve, which opens, allowing high pressure air to flow to the underside of the piston. The high pressure air in the lower chamber is discharged into the surrounding water through the source ports. The air from these ports form a bubble, which oscillates according to the operating pressure, the depth of operation, temperature and volume of air released into the surrounding water. It is forced back down to its original position by the high pressure air in the control chamber, so that once the discharge chamber is fully charged with high pressure air, the source can be activated again. The opening of the shuttle is very rapid, taking only a few
So I'm going to repeat it again.
A modern airgun seismic source element comprises of two high-pressure air chambers, an upper control chamber and a discharge chamber. High-pressure air, typically at 2,000 to 2,500 pounds per square inch, or PSI, is supplied to the upper control chamber from the compressor on board the seismic vessel via an air hose and slowly moves into the lower discharge chamber through an opening in the shuttle assembly. The source is activated by sending an electrical pulse to the solenoid valve, which opens, allowing high-pressure air to flow to the underside of the piston. The high-pressure air in the lower chamber is discharged into the surrounding water through the source ports. The air from these ports form a bubble, which oscillates according to the operating pressure, the depth of operation, temperature and volume of air released into the surrounding water. The shuttle is forced back down to its original position by the high-pressure air in the control chamber, so that once the discharge chamber is fully charged with high-pressure air, the source can be activated again. The opening of the shuttle is very rapid, taking only a few milliseconds, which allows the high-pressure air to be discharged very rapidly.
So I'm going to explain again about the operation of these air guns. So first, high pressure air is filling and stored in the firing chamber or discharge chamber, and then the air gun is fired, which release air and in turn causes a piston to move up. Thus, explosive release through a porthole by the action of a sliding shuttle that with piston at each end. So this allowing the air to escape the upper control chamber. So seismic energy is generated by rapid explosive release of compressed air through an air gun port in the surrounding to produce a primary pulse and oscillating bubbles. Here is where the air gun looks and how the bubble is produced after firing in a small tank through times. We have 1 millisecond, and after half milliseconds it start to expand, and 7 milliseconds within less than 1 second it expand this big. And here is how it looks like when they conduct the air guns, and they took the picture from the vessel where the bubble is quite visible here. For the air gun, depending on the size of the chamber, it will determine on how it is working. For example, smaller chamber at less than 70 cubic inch give a maximum resolution, which by mean can capture thin layer at very high frequency. Contrast if we use large chamber, even though the resolution is not as good as smaller chamber, however deeper resolution can be obtained as it give low frequency signals. They might be different in terms of size, frequency and resolution. However, both guns have a stable and repeatable pulse in terms of frequency composition and amplitudes. Besides, they can be turned to optimize the source signature within their own frequency bandwidth limit. Typically, the operation of marine source air gun is requiring to have multiple air gun towed behind the vessel, as shown here, at several meters below the sea level in a specific array of 3 to 6 meters. So this is because it designs to generate an optimal tune energy output of desirable sound frequency. Moreover, the usage of multiple air gun is for efficiency and quickness recoverable explosion. The advantages of using air gun is its reliability in terms of giving a good signal condition as its own environment, plus it is repeatable and not so expensive. In contrast, the disadvantages are the bubble pulse is oscillation mode, which producing a long pulse length. By looking at the graph here, how the bubble period is taken some part of early time before it returns to give the actual signal here. However, this can be actually improved by using multiple gun array that will produce a good seismic source signature. Another thing is only P wave can be created. So the question is why S wave cannot be created using the air gun. So you need to find your own answer for it. Some more, the environmentalists always did some demonstration on the impact of the seismic air gun to the marine animals. So the next marine type source that we are going to discuss here is sparkers. So basically sparker is a plasma sound source in which device that converting electrical energy into acoustic energy. Sometimes it's called a spark gap sound source. In short, we call it as sparker. So the sparker pulse is actually generated by discharge of large capacitor bank directly into the seawater through an array of electrode towed in a frame behind the survey vessel. Technically, it is a relatively higher power sound source in which dependent on electrical arc with an electrical arch with an operating voltage are typically 3.5 to 4.0 kilovolt, and peak current may exceed 200 ampere with a signal frequency in between 100 to 100 kHz, meaning that it has a very high frequency. Momentarily is vaporized water between positive and negative LEDs. So this electrical discharge lead to the formation and rapid growth of the plasma bubbles or air bubbles. So though due to its high frequency signal, most of the time this type of source is beneficial for seafloor mapping and surveying purpose. So technically, again, this part is telling us about how the sparker is working. Never mind, I will go again with the process. Here is the several component in the sparker system. For each firing, it store electrical charge in large energy or a large high voltage bank of capacitor. This green color one. So and then it release all the stored energy in an arch across electrode in the water. After that, the underwater spark discharge produce a high pressure plasma and vapor. This will then produce an acoustic sound energy. So basically, this is how the sparker will look like in reality, and you can read through the principal the advantages here. Because I want to highlight about the disadvantages. So the disadvantages is it produces a high frequency that will attenuate rapidly, in which by mean deep-seated structure will not be detected. However, due to its high frequency, the mapping of the seafloor can result a very good resolution. In the nutshell, this is how we can classify in more general for all the type of sources. So vibrators is the only non-impulsive source where it is continuously produce a sweep signal, while the rest is impulsive. Last but not least, here is the comparison, the type of energy produced for different type of sources. So in bracket, refraction energy and ground roll energy.